Welcome to my community. This is Physicist Rasha Radityatama. I'm going to talk about waves and wave behavior, and in this video, I'm going to talk about specifically refraction and interference. So let's talk about the big question that I'm going to answer at the end of this video, which is why might visionary leadership causes and or affect transformation? And the outcome that I'm going to talk about in this video today is being able to implement phenomena of waves and lights in a physical and geometrical optics phenomenon to provide a future forward generation. So basically, in this outcome, I'm in need to be able to use the phenomena of waves and lights in like real world situations and in geometrical optics phenomena to provide for a future generation. And for the first topic we're going to talk about is refraction. Refraction is the bending of waves as it passes from one material to another. It bends due to the change in wave speed as it enters a different material. For light waves, the bending of light depends on the optical densities or index of refraction of the material. We can see that from the picture. It bends differently when in different mediums. And basically, this is due to light entering another medium, and it can be anything, not just light, because waves are consisted of, for example, sound waves, light waves, and other types of waves. So it's not just based on light waves. And you can see for the demonstration in this video is someone using glasses, and you can see that from this picture at the end right here that wearing glasses gives you this effect of like being able to see better because it's more like zoomed in. And the process of bending light to produce a focused image on the retina is called refraction on the eye. And ideally, the light is refracted or redirected in such a manner that the rays are focused into a precise image on the retina. And these are the refractions, the example of refractions: rainbows, atmospheric refractions, distortion of underwater objects, telescopes, and prisms are all examples of refraction in the natural world. So the first one is rainbows. So rainbows are formed when light from the sun is scattered by water droplets, example raindrops, and refraction occurs when the light from the sun changes direction when passing through a medium denser than air, such as raindrop. So another example is the distortion of underwater objects, and water can also distort the shape of submerged objects. And when light rays pass through the curved surface of water, they refract differently at various points, leading to a distortion of the object's shape. And for the last one is a telescope. So a telescope made with lenses is called a refracting telescope. A lens, just like in eyeglasses that I explained earlier, bends light passing through it. And in eyeglasses, this makes things less blurry, but in a telescope, it makes faraway things seem closer. And for the second topic we're going to talk about is diffraction. So diffraction is the bending and spreading out of light or sound waves or around an object. So both light and sound transfer energy through the waves. And from this picture, you can see that it bends itself through the tight space. And this is the demonstration of it. You can see that in the video, there are tiny waves that are scattered around, and they make this pattern that we can see in the picture before when they are confined to a tight space. And so what's happening is the result is the wave fans out on the opposite side of the barrier, and it occurs when the size of the opening is the same size as the wavelength of the wave. So yeah, and this is the examples of the diffractions. And the real-life examples of diffractions include rainbow formation, sound wave spreading, and the pattern created by a CD or a DVD. And for sound wave, it's when a light wave or a sound wave encounters an object such as a wall or an aperture such as a door, and the wave energy bends around the object or opening, thus changing the direction. So when that happens, it's basically how we can hear things through the walls. And for example, somebody is in front of the door and we're behind it. Um, Diffraction is needed to for us to hear it. So yeah, and for the last one is DVD, and the two layers of the DVD are separated by transparent coating, and the CDs and DVDs show a display of colors when white light falls on them. This is due to the digital information or alternating pits and smooth reflecting surfaces on the discs forming closely spaced rows acting like a reflecting diffraction gradient. And for the last part is the answer to the big question. So the big question, as we know it, is why might visionary leadership cause or affect transformation? So I connected it in engineering, and in engineering, visionary leadership fosters innovation and drives transformative change by inspiring and empowering engineers to think creatively, push technological boundaries, and develop groundbreaking solutions. So thank you guys to the community for listening to my video today, and we'll see you in the next video. Thank you guys.